Welcome back to the show, everybody. Today we continue on with the X231 wheel project. Here's what we have on the docket. One back wheel that is, I would say, fairly solid and good enough to salvage as is. We have a few dings we're going to have to work out. Other than that, it's going to act as a guide for the really bad one. This one had fluid in for a while, and that's all that's left of the old valve stem hole. It should look like that right there, but it doesn't anymore. So the rim portion of it is a complete write-off, and we've got this new rim blank that we will be putting onto this wheel center. That's the plan anyhow. So first things first, we need to get this old rim blank off of the center. So we'll take this outside. That's going to involve the cutting torch and a grinder and probably a large hammer. So let's get into it. Yeah, look how much of that was rust. It took more time to melt the rust out of the way than it did to cut the metal back behind. So, all right, what I've done here is I've sectioned this into 4 pieces. I've made a cut along each, we'll call that web, all right, where the center pulls away from the outer rim. The reason why I did that, well, the outer rim is riveted to the wheel center. You can see the rivet heads here. There's 3 of them on each leg, all right, and the back side you can barely see. There's 1 rivet head, there's number 2, and just barely catch the outline of number 3 right there. What I'm going to do is grind each of these rivet heads off on the outside here, and then take a hammer and knock each one of these 4 sections away from the center. And when they riveted these originally at the factory, a lot of times some of this rim blank material was mushroomed back in to the rivet hole that goes through the wheel center. So you could grind all the rivet heads but still have trouble trying to hammer a rim off that's in one piece because so much of it is pushed into the holes where it goes through the wheel center. So that's why we're chopping it into 4 pieces, grind the rivet heads, pop 1 piece at a time. That's usually the easiest way to do it. So we did pretty well right here. We only ground through enough to weaken the rivets and remove that section. We didn't get into the wheel center at all. And this is what I was talking about earlier. You see how the metal has mushroomed down around all those rivet holes. That's why it's pretty difficult to hammer one of these intact rims off of the center because they're still grabbing onto it through that deformation. So, all right, we just repeat all the same steps, get these other 3 sections off. just knock the rest of the rivets out now.
Let me get all my protective equipment off here.
Show you something I noticed just a while ago. So I'm in the cleanup phase right now, of course. Get you all off the tripod. You know, many manufacturers used these same stamped steel center wheels, and I noticed when I cleaned over here, we have the JD part number, the John Deere number in this one, JD 1260R. And I was under the impression that these wheels that were purchased by John Deere for their tractors all received a stamping of a John Deere part number. The odd part, though, I'm not finding any old John Deere yellow on this. You can see the layers here. The top is a very faded Moline Prairie Gold, and then behind that is like a Minneapolis Moline Red, but then beneath that is just metal. So I don't know, maybe Moline purchased a batch that had the JD numbers on and they just painted over, or maybe this started life as a John Deere tractor wheel. Either way, everything's the same for Moline. So if anyone can expand upon that number at all, post up in the comments below. I'll just continue cleaning out here.
Please hold. Get everything off
so that I can talk to you all there. That's better. So it's a nice day, and I decided to start on the second wheel. Might as well get this clean. We're going to need it. And this is where we're really going to earn our stripes, because we have to take care of all of that, plus remove a few little dings. Not a big deal, just takes time. But I wanted to show you, I started cleaning on the face, and I uncovered another JD 1260R stamped into this one. No noticeable filler or anything covering any of that lettering, and once again, no John Deere yellow. We just have some very darkened prairie gold. You can see once the wire brush roughs it up, it returns to its normal color. A little bit of a reddish kind of oxide primer, and then steel. So maybe that's not a John Deere number, but I think it is. I've been under the impression that it is. So if anyone knows what's going on with this, please post up below. Once again, I'll be cleaning. Now that is a job that is nice to have done, am I right? But this rim cleaned up very well. It's nice and solid. It does have some rust pitting, but that's all right. I will get some good rust inhibiting primer on there before I put the tire on. The center looks very good. Valve stem hole is good. And this will be our guide for assembling this other one. Of course, the center is ready. I also just scuffed up the new rim blank while I was at it, but for now, I need to go clean up. Pretty much, I think it was about 6 hours of just grinding old paint and rust today. Never fun. Red sky tonight. Welcome back, everybody. To start out today now, the first thing I'm going to do is hang this intact wheel onto this hub, and I'm going to do a run out check. I want to see how close our target is. All right. Of course, you want everything to run as true as possible, but these wheels being just rolled and stamped the way they are, they're not going to run perfectly true. Anyhow, they probably have a little bit of this because it's not like it's from a machined billet or anything. But yeah, low speed, low stakes. It's nice to see where our starting point is. Anyhow. So, dial indicator set to a solid part of the chassis. I've zeroed out the needle, and I'm contacting this inner rib in here because my first setup, I contacted out here at the bead lip, and I got some pretty erratic run-out readings. Like I said, these rolled and stamped rims are not perfect to begin with, but this rim has seen some action in its day. So, we'll just take a reading down here. And right away we are 20, 30, 40 thousandths. And 50 thousandths. 60, 70, 80, 90, 100, 110. And now we start running back. Back, 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 back. Back to 30, 20, 10, 0, 10 the other way, and we are returning right back to the point where we started. Right there. I don't see it with my eye. Of course, this is such a slow running application. This really didn't tell us anything. So we'll see how close we can set the other one. So using this wheel as a guide, we need to locate our stamped center 4 5/16 of an inch in from this outside bead surface to the face of the wheel center. Of course, that offset is going to vary depending on which type of tractor you're working on. But in our case, that's our target. The only other main detail is to make sure we locate the valve stem hole to the outside and to center it up inside of one of those web openings. All right. And the only other preps I've made to our other wheel center is to grind down around each one of these rivet holes all the way around, because from the deformation you saw with the old rim blank, it also pulled material up a little bit around each one of those holes. That gives you high spots and just makes it an even tighter fit inside of the new blank. After I ground it, I flushed them out, kind of smoothed them with a flap wheel, so that we're not scraping and putting contact witness marks inside that new rim blank when we go and hammer this in. Okay, valve stem. Pull down there. One thing I'm going to try is the Goodson Press Fit Lube. I first started using this when I was pressing the pins and bushings on the Caterpillar D2 track. I don't know if it'll help here and keep metal from galling, but it worked very, very well for press fits there. So I don't have anything to lose, just a mess to clean up. One more thing, I'm clamping wood blocks at all 4 contact points because until we get this started, like if we would hit right here, it may want to kick up directly across. So those are acting like a brake, keeping everything absolutely down. And if you've got 240 pounds of lifeless dead weight to throw into the middle, that might be your friend too. So we'll start with the mallet and see if we make any progress. If that doesn't work, we'll bump up to larger and larger hammers until we find the one that does. We're started, so we can delete the wood blocks. And the big sledge with the heavy blocks seems to be doing the trick. Now that we're getting close, it's looking good. We have a ways to go, but I've cut these 4 spacer blocks, and these are the 4 5/16 of an inch standoff that we need between the top of the bead lip and, I should go like this, and the face of that wheel insert. So what I'm going to do is place one of these at each web, okay? And then lay the rim back down so that everything will be sitting on the floor with the blocks in place like that, and we just keep hammering that wheel center down until we contact the blocks. I think we're down on that block. Set the one 180 across. That seems solid. That's solid. Be interesting to see if we're walking at all, or if we're pretty much staying down tight. I think we're good. Yep. Yes. Solid all around. Okay, run out check on the new one. Remember our last one, it was all over. 10, 20, 30, 40, and now we're going back down to 20. Now we're 40, 50, 60. Now we're going back to 50, 40, 30, 20, 10, 0. That was our original starting point, and we're halfway around, okay? So that's the variation and a half of a revolution. Now we're -10, -20, going the other way. Now we're back to 0 again. That's our 0 point. We're probably 2/3 of the way around. Back to 10, 20. Now we go back to 0. Now we're -10, back to 0. 20, 25. Now we're heading back. And right about 0, that's where we started. Valve stem holds my indicator. This one's closer than the other one. I think a lot of that is just in the variation of the rim. So let's get up and eyeball. Let's just eyeball the bead, all right? As I rotate it, I think we've got a pretty square on view right there. I'm gonna get this dial indicator off so we can really sail it around. To me, it looks like it runs true. True enough for a tractor. Personally, I have no issue with that at all. I've been around the perimeter with the gauge block one more time. Everything looks good. So we can make this permanent. Look at the other wheel over here. So it is riveted, yes, but we've got a tack weld at the back end of the web right there. And up on top, there's another one. We have number 3 right there, and there's another one down on number 4. I have to believe they tack welded the center to the rim before they did any of the riveting. So we will just do the same. So with good tack welds holding everything in position, I spun it one more time on the tractor with the dial indicator this time. Nothing changed from the prior reading, so we're still set. Next step, transfer punch time. We've got 3 7/16 diameter holes where the old rivets used to be on each web. So with the transfer punch, we'll line up, establish the center, and drill every one of these out to the full 7/16 diameter. And then I'll put a temporary 7/16 bolt and nut in each hole. This is just to make doubly sure we're holding everything in position. All right, for now. Tighten these in with a wrench, and we'll repeat for the other 3 webs. And once you get all the bolts put in, you're done, ready for rubber. No, we're gonna rivet this, all right? We could weld it or we could rivet it. We're sticking true to the original design, so I'm gonna go with the rivets. Here they are right here. These are a 7/16 diameter shank domed head rivet. And what I've done is cut a pretty generous countersink around the top side of every one of these holes, okay? So the rivet goes in, we will heat it, and we will mash it over, peen the end of it so that the displaced material will fill that countersink void. And that is how the rivet is going to maintain its hold on everything. So I've turned out this backstop support, okay? It will support the domed head of the rivet from the back side, just like that. And we can place this on one of the heavy steel working tables outside and basically set the whole rim and rivet and everything right onto this backstop so that it will keep the rivet well cinched out against the web, and we can do all the heating and the peening and the mushrooming over on the other side. So that is our plan. Let's take this outside, start making some noise. And here's the setup. So the way I do this, I put the rivet in the wheel first and then just clip that vice grip on it so that it can't fall out. You see I have this flat iron clamped to the heavy welding table, and it has these holes all the way down. So like the hole on this end, there's another one down here. And that hole is what my support adapter just drops into, okay? So it is supporting the rivet on the back side, and the full weight of the wheel is, you know, exerting pressure down on the rivet, so we can do all of our heating and hammering out here without having to worry about driving the rivet downwards. And you just position the bar on the table in a manner so that you get proper overhang so that the table leg supports the lower portion of the rim, and it holds it all nice and vertical for you. So at this point we just take the vice grip off and we will heat, hammer, and peen until that one's set. We're going to have to heat a few different times. Oh, that's just my airline getting cold. I thought it was the torches still on. Yeah, we're fighting the cold out here today, but that's what we're going for. So this will be ground down and flushed a little bit, all right, but for the most part we've got good mash out filling that whole countersink. We're standing a little bit proud, which is all right, but yeah, we will flush each one of these with the grinder afterwards. So that's one. I've got 11 more to go, and my camera battery has just about had enough of the cold. It is ready to stop playing. So you all know the process. You get the idea. We'll take another bolt out, reset with another rivet, leapfrog over to the support adapter, and go on until we've worked ourselves all the way around. So, all right, let's get to it. Just bringing you all back real quick, giving you a view. All 12 rivets are set all the way around. You can tell by the discoloration, we had excellent heat transfer, and everything turned out very well. Rivet head's nice and tight. So I'm going to flush these real quick with the grinder. Sun's getting low and it's time to go. So bring you all back after we've done that. And here we are after the grinding. Flushed all those rivets out nicely. We have some slight bumps where the mushroomed ends are, but no sharp edges and nothing that can catch or chafe on a tube. And looking at the backside, once we get all that cleaned up and painted, it will look almost like a factory rim. So I'm happy with how it turned out. We have a pretty good matching set of rear wheels for old X231 now. This was another big step. We're that much closer to getting that into rolling status. So yeah, looks good. I honestly don't mind replacing these rim blinks. It's a bit of work, but it's still better than cleaning all that old rust. So all right, everyone, that does it for another one. Thank you, as always, for watching. And be on the lookout for the next episode. We'll either be doing new tires onto these rims or starting work in the bell housing of the engine. Either way, I hope to see you all back. So thanks again, everybody.